everybody. Welcome to the last session of Integrating Scratch webinar. This is Haruna.
Hi, this is Rashmi.
And Nick is unable to join us tonight, so it'll be just the two of us. Again, this is the last session. We did 3 sessions already. This final session will cover math and variables and iterations, although I forgot to put that in here, but it's fractals and things like that that Rashmi will go over. And today's agenda, we will go over some of the things from last week and then go right into iteration and then go into variables. So we have a lot to cover today. And then we'll go over the homework, your final homework for this series. For last week's recap, rather than showing you the projects from the teacher's homeworks, we're going to actually answer some of the questions that we got on the exit survey. So on the exit survey for session 3, one of the questions was, what is something that you would definitely want us to cover in this last session? And so there were some that we could definitely address right now, so we are going to do that. One of the things was how to make things disappear slowly. So I'm going to go right into Scratch. So we already did the hide and the show, which make things disappear instantly and come back. But if you wanted to do this slowly, what you would do is use repeat. And there's actually another way to make things go away, which is this color effect. Whoops, sorry, I didn't mean to click on that. So there are a lot of different graphics effects you could do in Scratch. And one of them is a ghost effect, which makes things fade. So if I say, let's see, I'm going to start by clearing the graphic effect to start from a clean slate. And then I'm going to say change ghost effect by 10 each time this loop happens. And the way the ghost effect works is it goes from 0 to 100, 0 being completely opaque and 100 being completely transparent. So if I repeat this loop 10 times, it becomes more and more transparent each time by 10%, I guess. So let me go ahead and run that and show how that goes. It's going a little fast.
Maybe we can put a weight.
Yeah, let me put in a little weight because it's going a little too fast. Okay. So now it's fading slowly. Slow. You can also play with some of these other color effects. The color changes the shade of the color. And that one, I believe, goes from 0 to 255. Fisheye is kind of fun. It makes the sprite bulge like a fisheye lens. And all of these things will be undone if you do a clear graphic effects. Whirl is like a little swirling effect.
Right. So transitioning, you can use it for transitions.
You can also pixelate it, and that's another kind of fun way to make things disappear or appear to disappear. Mosaic.
Right, that's it.
So there's a lot of different fun effects, but the ghost effect is very useful for making things disappear. So that was one question.
I also want to point out how Haruna added 0.1 second as a wait time, just to make sure you see the transitions quickly, because usually people do 1 or 2 or 3 seconds. So just keeping that in mind as well.
Yes, we can do less
0.1
than 1 second. So let's see what the second question was. Oh, one of the questions was, can you make a sprite move like a human, like a more realistic animation? Which is an interesting question. We talked about costumes before. And so the answer to the question is yes and no. It depends on what kind of motion you're looking for. And we talked about how this cat has 2 different costumes. And we can make it look like it's walking by changing costumes.
Right.
And again, I'm going to put in a little weight in there. And I'm also going to move it at the same time. So now it's kind of walking. You can also do that with some other sprites. Some of the other sprites that are built into Scratch have multiple costumes that will animate automatically. So this Avery walking is one of those ones that have have different costumes built in. It's actually got 4 costumes built in with different parts of the walking process. So going back to the cat and copying this script right into
The cat.
Avery. I'm actually going to repeat this a few more times. So, you know, and then you can play around with the movements. I'm going to make her move a little bit more time. Maybe make this a little bit faster. So you can get a little more realistic in terms of motion. Now, the reason why I said yes and no is because you still need these costumes.
Right.
So if you don't have these costumes already there, it's pretty challenging to make a sprite move like a human. So if you're, let's say, using your own photograph as part of Scratch, to make that move like human, you have to have different clips of yourself at different points of the motion and have it animate that way. If you have an animated GIF file, a lot of web online animation uses animated GIF file. If you import that into Scratch as a costume, all of the frames of the animated GIF will come in as a different costume. So that's an easy way to get an animated effect. But creating it from scratch is pretty challenging. But if you have all the costumes all set, yes, it is possible to make it look a little more human than just moving around a still body. So that was the second question. And the final question that we thought we'd like to share is how to make a button that you can click to make something happen. And we actually covered this in the third session, but I'm gonna just cover it one more time just to make sure. So the key here is this when this sprite is clicked. And when this is clicked, you can make anything happen that is tied to this block. So I can even make Avery walk again if I click on this sprite. Now to make another sprite do something or make the backdrop change or something like that, or actually backdrop change, you can do it from here. But if you want the cat to do something after that happens, then that's where the broadcast comes in. So we did talk about broadcast last time. And so we can say when the sprite is clicked, broadcast message 1. And on the second sprite, we'll have to say when I receive message 1, then do this. So I can say, well, click Avery and the cat moves. So when this sprite clicked block and the broadcast blocks are what will make these type of things happen. So those were the 3 questions from the third week survey that we wanted to share. Now let me bring myself back to the slideshow. So now moving on to new material.
We're just going to show you some examples of projects that use variables or different types of logic or clicking, and just a little bit of examples of, we'll probably go back to you for voting example too. So the first game is a simple multiplication game that, so it shows you the multiplication game, which can be played in the 4th, 5th, the 6th grade. It's basically taking an input, has some interactive feature. So I'm going to play it for you. And it says, what's your name? So it's asking me for an input, which is a variable again. So my name is Rashmi. I hope that's correct. So it says hello. It recognizes the input that I have given it. And it says, let's get started. Now, what's 2 times 2, which is 4. I put that in. It says correct. So there is some sort of a looping action going on which checks for my answer. So if I say what's 7 times 6, I know my multiplication tables. I'm going to say 42. Click. It says, sorry, that's not the correct answer. But it doesn't stop me there. It gives me another chance. It's 5 times 10. That's 50. I say correct. And so on and so forth. So the game goes on. If you look at the code just a little bit, you'll see that there is, when clicked, as Haruna mentioned, there is, it's asking for an input. It has a wait time. It says certain things, but it uses the broadcast command that we talked about last time. And then it's asking me the question. And as we suspected, it has a forever block, which then again checks for my answer. In my first case, it was 2 times 2, which is 4. So it says correct, and it checks for my score. And that's the variable that we will be looking at, because in here, when you look at data, there is a variable called score. And we'll look at how to create a variable and how to add variables later on. Again, it does the same repetition of the blocks, but it's a really great program to see some interactivity. The second program that we wanted to show you was that of drawing shapes, drawing geometric shapes. So in this case, it's a neat little program because it gives you an option of, let me show you. So it says there is a small note that we have added which says click on a letter to draw the shape, and the three options that you have are square, triangle, and parallelogram. So in this case, in order to start the program, I clicked on my start button, but I have to use a keyboard control in order to show my square or draw my triangle or a parallelogram. In this case, I'm going to click S, which basically draws, my octopus is going around and drawing a perfect square, a unit square on top of that. Now I want to draw a triangle. So I'm going to press again T, and it does so. A wonderful, nice equilateral triangle, or isosceles actually. And a P would give me a parallelogram. So this is a nice way of, again, working. If we look at the code just a little bit, we have three little commands. We're going to look at the two that shows up on the screen. When key S is pressed, and you have multiple options here, but when key S is pressed, which is for a square, it clears the screen, it waits for a second, shows, and then goes to point X0, Y0, which is the origin of your graph. And then the glide command takes care of drawing that square. There is a pen up, pen down command that we looked at last time in one of the webinars. So we are trying to use some of these commands together to form, the shapes that are getting created on the grid. Same thing with the key that talks about the triangle, and you see that the glide command changes with respect to the X and the Y, and how that forms up the triangle. And again, at the end of each command, you see that there is a hide, which again cleans off the screen, and then you can start again. This was our second example, and the third one is that of a parabola. This is for a little bit of, parabolas get introduced at grade 6 onwards, so you can pretty much start talking about the shapes of the parabolas, what the directrix is, what the focus is, where is the axis of symmetry. So this can be changed up into many different, or vertical alignment across different grade levels up until 9th grade, I suppose. So let's quickly look at this parabola. It is a tiny bit slowly moving, but as you can see, it is plotting the points for the parabola just like it does so on the graphing calculator. And you will see that it's a parabola, its directrix is close to that of the x-axis, not exactly on the x-axis. The y-axis is again bifurcating the parabola in the two equivalent shapes, so that's again your axis of symmetry. And there is a lot of concepts that you can sort of talk about mathematically, and when we look inside the code quickly, there is, again, there is an if loop that we have talked about. There is some more stuff that we are going to talk about in terms of creating your own blocks and how you can modify them. That's included in this program. But again, just remembering that we have our pen up commands, where we have commands where we are setting up our variables. We have our looping commands like the if else or the if commands that we've used before. This gives you a little bit of an idea of how to integrate many of those commands that we've talked about before. I'm going to stop it at this. That's a beautiful parabola.
And if you're doing any of the math projects, the backdrop you see now, and when the one you saw on the shape program with the coordinate grids and the x and the y axis, that's one of the available ones in the Scratch built-in backdrops. So it's really useful if you're doing any sort of math programs.
Yeah. They've really thought about it, and it gives you that additional advantage as opposed to bringing in a coordinate graph.
And the
into
X
it.
and the Y values correspond to the positions on
Right.
the screen. So you
Excellent.
can calculate the numbers and plot it. It shows up just right.
Perfect.
All right, so I just wanted to show you this quick program. This is not really a math program, but it's more of, it could be something that could be used for anything really. Let me run it first. So it first asks you for a yes or no question. So let's say, do you like snow? And so now it asks a question, and you could go around asking people to vote. So, you know, I'm clicking, I'm voting, we're clicking. Lots of people don't like snow. And when you're done, you click on done, and it graphs the results for you.
That's wonderful.
So we have a couple of different sprites with a variable yes and no that we will show you how to set that up later. And the math of this comes when you're actually taking the number of votes and turning it into a percentage, so you can actually graph it. So this graph is not just a number of votes. It's actually a percent. So even if only one person vote, this line will go up all the way. It's not going to just be one. So so that's where the math comes in. But other than that, it's, it uses user inputs. It first asks you for a question, and then show that question on the screen. And then it's also interactive in that you can have multiple people answer yes or no, and then it graphs the result for you. So
I really like this program because
this could be a history lesson too, if you talk about the whole voting and the democratic process, and then we could have students vote on different issues in class.
Absolutely. And we'll be adding most of these or all of these examples to our, if you have not already,
in the studio. They are all in the studio.
They are all.
I just added it about 10 minutes ago.
Excellent. Before we go into another example, which sort of talks about iteration, which is one of the most important, or one of the important concepts of programming. So we had this little graphic from, BBC does a really amazing program called BitSize, and they talk about programming, and they use this graphic immensely. So iteration, what is iteration? It's a process of repeating steps. And so in this case, it's a splat the rat example. We know what we are doing at each stage. So thinking of it as a program and how we don't have to keep on repeating that step manually, but the computer can do it for us. So that's essentially the core of iteration. We are going to look at the second one. Why is iteration important? Iteration allows us to simplify our algorithm, stating that we will repeat certain steps until told otherwise. So there are two types of programming iterations. It's also referred to as looping, and you probably have heard of looping many a times in programming. And there are count-controlled loops, which is essentially you say, okay, this loop is going to repeat for 10 times, and that's set, and it will repeat for 10 times. And the second one is condition-controlled loop, which is essentially until a condition is met, this looping will continue up until that condition again is met. So sometimes in an if-else statement, this condition met, then it goes into the next logic that you have stated. So these are just basic fundamentals of what iteration does. So now we are going to look at a program that essentially drives on the logic of fractals. You've seen Coach Snowflake, you must have seen beautiful fractals being designed, and they use iterative recursive logic within it to have those beautiful patterns. What we have here is Dory, who is going to repeat for some time, and you're going to see her as an iteration. So let me quickly go to Dory's iteration. When I designed this example, I was looking at many different sprites, and she seemed like a really friendly purple sprite. So let's look at Dory and what it does when we run this program, and then we'll go into it and discuss a little bit about what making a block and how we add a block to the program and how does an iteration look like in this program. So let's run this. Fractals are a great way to learn about iterations. She also says iteration is a process of repeating. So in the first step, you see that Dory is replicated multiple times. And then you see that she's still getting replicated as we're moving forward in the X forward direction. So let's see how many times she goes into the repetition. There is this tiny bit of mnemonic value that I've associated with Dory just to see how many times we repeat. And when we see the program, you will see where that weight comes in. We'll stop. That's your final fractal. Essentially the logic of fractal. We'll stop that and let's look at the program. In this, as you see, we're clearing the screen, we're going to X, Y. There is, all the say commands that we've talked about, it's just sort of, commenting on the program and switching costumes. Then there is something called something iteration. Now that's a block. Where did that come from? It had to be a block that we made, which means I made a block called something iteration, and it has some initial value that I've assigned. How do you make a new block? So now we are going to make an example block. Obviously, we will remove it. I made a block called Dory. And when I am making a block, I can add different types of inputs. In this case, I have 4 number inputs, but I can add a string input, I can add a Boolean input, or I can add a label text. With Boolean input, if you remember last time we talked about conditions in an if-else statement, or
the true and the false.
Right, the true and the false. So you can use those as an input, which is a condition. In case of string, again, it's a text. And we are going to add, say, a number input. Let's say, what do we add it as? It's going to be, let's say, 1, 2. I'm just adding number inputs because the something iterations in this case is, I do not want it to run without screen refresh. So I'm not going to check that option. I'm going to just say OK. If you see, the moment I said OK to my new block, it gave me a definition of that block in my program, which says define Dory 1, 2, 3, 4. And I can change those values in here too. Something similar to down here, which says define something iteration, iter, which is my first iteration variable, X, Y, and S being my count. Then I put in an if statement. I'm going to remove this block. So when I go in here, I have an if statement, which pretty much says iter is less than 0. Oh, sorry, iter is greater than 0. My apology. It goes to X and Y, whichever is stated. In this case, the initial is 4, 0, 0, and my count is 200. So I'm going to set the size to S%, which is, again, the value 200 that I have input at the beginning. I'm going to stamp, which means the Dory shows up. And the first Dory that shows up is pretty big. That's the 200% of her size. Then if let's say, if I remove my this whole block, and if I now run this, what does it do? Right, so it essentially took the negative X axis and it repeated Dory 4 times because it is checking for my condition. If the condition is okay, if iter is greater than 0, it goes in, does that. Then again, if iter is greater than 0, which is in this case, the second time it will be 2, it goes and stamps Dory. Third time, 3, goes and stamps Dory. And then, as it goes, it reduces here. Iter is reducing by 1. So 4, 3, 2, 1, and then iter is not greater than 0, so it stops at 4. That's the 4 iterations you get. Now, I also wanted that program to run multiple times, which is the idea of a fractal. So I'm going to bring in the something iter, again, the same block, and I'm going to add, in this case, the first one, I am reducing iter by the size. Do you see? I'm reducing the iter, and then x minus s by 2, which is the size, and I'm subtracting it from my x. In the second one, I'm adding it to the x, so it's going forward in the x direction. That's why the first, it goes back, then Dory starts adding, but in a forward x direction. So let's see what happens. So I'm going to remove some of these say statements so that we can make it faster. Perfect. So now you see that it is iterating Dory on the x-hand side, and then it is again going forward with multiple Dory sets of 3 on each direction towards the x-positive axis. So this is one way you can draw the fractal. It seems a little bit complex, but the idea being something iteration, which is the block you form, and it identifies with, you know, the variables that you've given in the iteration, how many times you want to do it, and the concept of looping, which is, it's essentially looping 4 times because our count as we give it at the beginning for iter is 4. So you get to decide if I change this count right up here to say 3, then Dory is going to show up only 3 times in the negative x direction, and then you see 1, 2, and 3, and that's less number of Dorys, hence a less complex fractal. So you can go 4 or you can go 10, and you will see that much more complex pattern in terms of your fractal. And then just, you know, to see, it's a great idea to see your fractal, which is the concept of wait time that we've talked about in our previous webinars as well. Adding a wait time or sort of reading the variable. In this case, I want to read iter, which is how it's reducing or increasing. I want to see that, and I've added 2 seconds, but you know what? We want to make it quick. So let's do 1 second, or just like what Haruna did. She did 0.1 or 0.2 seconds. So we are going to stop it, run it one more time. And in this case, we have 3. So if you see, the count is essentially the count that of a iter, and how it decreases and slowly increases in the second iteration. So there you go. That's your Dory iteration.
We're going to shift gears a little bit and talk a little bit more about variables. So we mentioned variables earlier today when we were showing you some of the examples. Variables is a way for you to store numbers or letters or any sort of data to be used later on in the program. So, and to create a variable, you first go to the data tab and then click on make a variable. And I'm just going to say cat. I'll just call it cat. There's an option to make this variable available for all of your sprites or just for the sprite. And if you only have 1 sprite in your program, it doesn't really matter. But if you have multiple sprites in your program, it's important to pick one or the other. Usually for all sprites works just fine. Once you do that, you get a block for your variable. This is what represents the content of the number or the number itself. And then there's different options. You can set, I'm going to drag it out so you can see it a little bit better since my right side is a little bit bigger. You can set your variable to a certain number. You can change your variable by a certain number. So this block basically would add 1 to the existing value of cat. You can also show and hide, which is talking about this display on your stage. So this display here shows what value your cat is right now. If I change this to, let's say set cat to 1, then that number up here also changes to 1. And sometimes you want this number up here, sometimes you don't. And you can also move this around to wherever. So and I can hide it if I wanted to, and I can show it if I wanted to. There's also, if you right click on this, there's a large readout, which doesn't give you the name of the variable, but it gives you the number itself. It also has a slider mode that you can slide and see the number that way. Now, variables are useful for things like keeping score in your game. So if you made a game and you want the score to count up, where you have like numbers of lives left or things like that, it's a really nice way of doing it. Or it's also a good way to take user input. And so like the multiplication example that you saw, you know, a user answers the question and you want to compare that to the real answer. So you need something to do that with. Drag these back in And one thing you can do is there is a block called ask, the ask block.
Right.
This is a question that you saw earlier. Put a green flag here. So, and when you ask a question and you type in an answer, it could be a number or it could be letters. The answer goes into this answer block, which could then be used in a variable as is, or you could actually assign it to another variable. And the reason why you might want to do this is if you had more than one question to answer, if you were going to answer, like, let's say 2 different ones, each answer is going to be called answer. And the newer answer is going to overwrite your old answer, unless you store it in a different variable before it gets overwritten.
Absolutely.
So if I say something like,
oh, you can't set a condition for that. Yeah.
What is your favorite number? And ask that. And I can say 8. And now my cat variable has 8 inside.
Right.
And once you have those variables and things all set, you can start manipulating that number. So let's say I wanted to add something else, or
you
something to do.
Cat plus 2. You could do that.
Yeah, or let's say I want to ask another.
Right, you could add 2.
So I'm going to make another one. So what's your favorite number? And I'm going to ask another one. So how many cats? And how many dogs? And I am going to set my dog variable to my new answer.
Right.
And then I could say something like the total is cats plus dogs. So let's see. Where is my say block?
It's right there.
So
let's say.
Say again.
Right.
No, I don't want to do that.
Right.
Put that here.
Right.
Cats plus dogs. I don't want to say that for 10 seconds.
Right.
So now I have, let's say I have 2 cats and 3 dogs. So the total number of pets that I have is 5. So you can start manipulating numbers that way and using your variable inside equations. You can also do that with text. So let's say I had a text or string. So if I say, what is your name? And what is
your first name or last name?
Cat's name.
Right. And what's your dog's name?
And now I can set my variable cat to my answer. Here's my answer.
Right there.
And you could also manipulate text by joining different words. So I can say, hello, cat. And we can say something like,
say,
hello, cat. This is literally just joins the text together, so it's important to have a space after hello. So I just added the space. So what is your cat's name? Snowflake. Hello, Snowflake. So you can start doing some literacy projects if you want to ask a student's name and then use that name as part of a story.
Right.
Or anything like that. You can make the program a little bit more, feel a little more personalized that way.
Right. With history, you could have the states and then, their capitals, you could do that, or countries and the capitals. So there are many different ways you can integrate this into your existing curriculum.
Yes. And this is one more program that we wanted to show us, the Polygon program. So
oh, yes.
Go into that. So this program will ask you for an input. Enter a number that's larger than 2. That's going to be the number of size of my polygons. I'm going to say 6. And the cat will draw you a polygon.
And a nice equilateral hexagon.
Yep.
Which is multicolored.
Spacebar to continue. And I can do something else. Let's say I'm going to give it some huge number. So the larger the number, the closer to a circle that you get.
Right.
And at this point, I enter 300. You're pretty much going to get a circle.
Right.
because
Which is a great concept for students to
Yes.
see too, that
yes,
how circles came about.
yes, as the number of sides approach infinity, you
Right.
basically get a circle. And another math lesson in here is to figure out, in your program, how many degrees do I need to turn to get each polygon?
Right.
And it turns out that the angle, let me try something a little easier to see. So the number of degrees that the cat needs to turn at each corner for a polygon, it turns out it's
Proportional to.
it's like 360 divided by the number of sides. And so students will need to figure that out. I think it's in here somewhere. You
Right,
set the
it's right
angle to 360 divided by I, which I is the number of sides that I just put in.
Right.
I do some calculation on the length here. That's just to make sure that the polygon that I draw fits on this screen. Because if I just make this length of the side a constant, then sometimes you'll get a tiny, like if you put in 3, you'll get a tiny triangle. And then if I put in 100, you'll get a giant circle that doesn't fit on the screen. So I did a little bit of math to figure out what I can fit on the screen. That was by trial and error. And then we know the angle is 360 divided by the number of sides. And then it just goes to a point and picks a color, pen color by random, and repeats by I is the number of sides.
And then
this other loop is just to make the cat look like it's walking. That was completely unnecessary. It's a cosmetic touch. But everything else, it just needs to move a certain amount and then turn, move, turn, move, turn, move. And then hit the space bar, goes back up, ask for a new number.
It's a great interactive way for students to see math in action, essentially, because programming does use a lot of that, and you can see visually how that is represented on the screen.
The homework for this session, this is going to be your final homework, is number 1, to fill out the exit ticket one more time for the last time. And then to create an interactive program with at least one user-created variable that is used somewhere else in the program. And now the variable could be the orange variable that you create, or it could be like the purple one that you did under the main block. Either one is fine. And then some sort of operation done on the variable. So operations are like the pluses and the minuses, or the join text, those things. And then we also want you to try to incorporate as many of the other ideas as you can, since this is the final project. We want to make sure you kind of build on what you've learned. And again, because this is the last project, I want to make sure the topic is something that's related to the field that you teach. I know a lot of you have been doing that already for the existing programs, but this time we want to stress that it really should be connected to something that you teach. You could make some demonstration type program that you could show to your class, or you could pretend you're a student taking your class and think about what kind of projects they might be engaged in.
It serves as a great example to weave into your existing class or existing project, and students really are excited to see something that they will be doing. So
once again, if you need help, we are available by email, Google Classroom. Nick will have his final office hour face-to-face, 4 to 5 on Thursday, and we'll also be online from 3:30 to 5.
Absolutely.
And the course technically ends on April 10th. That's when the last homework is technically due. But we will continue to take assignments beyond that. So even if they're late, please continue to submit it to us. We will be crediting you with the 10 PDPs in my learning plan as soon as you complete all assignments from the 4 weeks.
Makes sense. It will not, the Google Classroom will not close on you.
Yes, Google Classroom will keep on going. We'll keep on checking. So just if you somehow submit a project like 2 months down the road and we're not checking, just send us an email and we'll definitely go back to take a look at it.
Some tips and thoughts again. Always plan before you begin. Storyboard is critical. Test as you go, and always test smaller pieces of your code to see how it's working and then how it fits into the bigger picture. There are many ways to solving a problem. So always try and look for new things. Computers listen to you. So a program will only do what you let the computer know. Never be afraid, always scratch. And please feel free to play around. Scratch will not break. We've tried breaking it. It does not break. So it's very forgiving.
And down the road, as you're working on different projects, if you have any questions, just let us know. It doesn't need to be related to this course. If you're doing something else in Scratch, or if your student is working in Scratch and has a question, just send us an email. We'll be happy to help. There is one last question from the survey that I completely forgot to answer, so I'm going to jump right back into that. And that was, are there any lesson plans or curriculum options in Scratch that you could use in class? I know for this particular webinar series, we did more activities and not really a curriculum. So I do want to go back and address that. Scratch has been around for a long time, and people have made quite a few different options for curriculum. So one of the ones, one option is right in Scratch. If you go to help, there is a link to Scratch Ed. Scratch Ed is a community of educators using Scratch. And there are a lot of different resources here, including activities and curriculum. I believe it's under here, the resources. The Scratch Curriculum Guide is the sort of official one that's made by the Scratch team. And it's a very actually extensive, long curriculum. So I'm not sure if you want to use the whole thing, but this is definitely a place you can look for resources in terms of what activities, how should you get started in this. So the downloading the guide is right here. It's from the people who made Scratch, so it's as official as you can get as far as Scratch goes.
MIT Media Labs.
A lot of the other things are made by users, which I know a lot of them are equally good, but this is like the official one. And again, that was under Help, Scratch Ed, Resources, and then curriculum resources. Another one that we like is CS First. So CS First it's actually done by Google, but it's a Scratch curriculum that Google made with after school in mind. So it is, you can say start a club, and you can actually register, and it comes with a lot of materials. So it's broken up into several different units. Each unit has lesson plans and activities. And because it's geared for after school, it's not really tied to like school curriculum. And it's got a lot of fun topics like storytelling, fashion design, art, sports and music and things like that, and even game design. And you could kind of pick and choose. You don't have to go through these in order. So if you have an after school club, or if you have a student really interested in doing this but doing it on their own time, or if you're doing this as part of like a computer class that doesn't really that doesn't necessarily have like English or math curriculum focus, then this might be a fun place to start too. This is CS First. And if you're in CS First, students can set up their account, and it tracks their progress, almost like in Code Studio. It basically tracks their progress. It has videos built in. It's meant for students to kind of run it by themselves. So so teachers are more just there to facilitate, but you don't really have to instruct so much. A lot of the material are already there. So this is another great place, not just for students, but also for you if you want to just get a little refresher on what you learned during this webinar, or go a little bit further in it. This is a good place to start. So that is, again, CS First. If you Google CS First, or just go to www.csfirst.com, you will see it right there. Explore around,
and there are a lot of resources out there, just like what you're submitting. That also becomes part of the bigger resource.
Thank you for watching. Thank you for joining us. This is the last session, so we're signing off for good.
Absolutely.
But we'll be looking forward to receiving your assignments. All right. Thank you. Bye-bye.
Thanks for tuning in to our webinar. If you learned something new, give us a thumbs up, or leave a comment down below in the comment section. If you're looking for more videos, click on one of the videos to the left side of the screen, or explore our YouTube channel, and don't forget to subscribe.